Hey, mathletes. What we're going to talk about in this video is comparing and interpreting rates. There's going to be a few definitions, so some vocabulary that you're going to need for this unit. So it's a good thing to maybe start to think about writing those down somewhere. It'll help you as you go through the unit for sure. Okay, so first off, what the heck is a rate and how do we apply them? That's the goal for today. But before we talk about that, or at least we know what we're trying to get to, let's talk about these definitions, these things that I got to know. So there's three for today. Number one, what is a ratio? Well, a ratio is just us comparing two or more quantities, but they have to have the same units. So really, we're comparing one or more things, one or more items, but they have to have the same units. Okay, that's the big thing, same units here. And when we're doing this, when we write a ratio, we write it like this. So that colon there is, we would say 2 to 5, or I would say 7 to 9. Okay, and so you're comparing two or more things. Again, I could even, like I said, put down another one here like that, comparing three things, but they have to be in the same units, whatever those happen to be. Okay, a rate, which is a really, really important thing, is a comparison of two quantities, but in different units. So we're comparing again more than one thing, comparing items, but in different units. Okay, and my favorite rate is when I'm driving my car. Kilometers per hour, right? So if I was driving down Crowchild Trail going 80 kilometers per hour, well, there's my rate. I'm comparing distance and time, right? Kilometers and hours. A unit rate is super, super useful when I'm trying to compare two different things together. And what a unit rate is when we're trying to figure out exactly how much I'm going to pay, how fast I'm going, but per one unit. Okay. And so this is really useful, especially when we're shopping. It's a really useful way to see how much I'm being charged, which one's the better price. Okay. So let's take a look at these things and see just kind of how, they're not going to be super difficult to work with. Okay, so use unit rates to figure out which school has larger class sizes. Okay, so let's figure this out. Well, school A has 78 students per class. So for school A, if I want to find the unit rate, what I'm going to do is I'm going to say I've got 78 students. I'm just going to put S for students per 3 classes. So my unit rate, friends, what I'm going to do is I'm going to divide these things. And what that gets me is 26 students per one class. That's my unit rate when I've just got a 1 there. Well, I do the same thing for B. So school B has 115 students per 5 classes. And when I divide that, I get 23 students per 1 class. So now I can say, okay, which one has the larger class sizes? Well, clearly school A has the larger class sizes. So that's the important thing about unit rates. A lot of people would say, oh, well, look at school A, they've only got 78 kids. Well, yeah, but in 3 classes, so their rates are actually higher. Okay, let's try another one. Like I said, when I'm grocery shopping, a lot of the times you want to say to yourself, like, am I getting a good deal here? So I'm buying a bag of apples, which I buy a ton of because I've got kids. And so there's green and red, and there's a 5-pound bag and a 7-pound bag. And it says, which one's the better deal? Well, I'm going to find the unit rate. So for my green apples, what I'm going to say, and I always want my units, friends, $4.95 and 5 pounds. Okay, so I do that and I divide and I get 99 cents per 1 pound. That's my unit rate. I always find it interesting too. We're in Canada. We still talk about things in pounds. It's ingrained in us, right? Even at the grocery store, it's still in pounds. They have to list it in kilos. But anyway, Just an old man thing I'm thinking about right now. Okay, so my red apples, well, they're 6.30 per 7 pounds. So when I divide, my unit rate is 90 cents per 1 pound. So if I'm thinking to myself, okay, which one's the better deal? Well, the red apples are a slightly better deal, right? Now, 7 pounds is a heck of a lot of apples. So I might not be buying 7 pounds of apples. That's what I want to think there. But in terms of what's simply just a better deal, well, the red apples are a better deal. Okay, let's just try a couple more of these ones. Now, you're going to go run a race, and you ran a long distance, 10K, in an hour and 4 minutes, and you ran the 500-meter dash in 2.5 minutes. Okay, so which one did you run faster? Well, to run faster, that means we're talking about speed, and we can compare this in either kilometers per hour. Like I've got two different things here, kilometers per hour, kilometers per minute. Like they're both being measured in two different ways. So how about let's do this one in kilometers per minute. Right. So your long distance rate, kilometers per minute. Well, you ran 10 kilometers, and in an hour and 4 minutes, well, that's 64 minutes. So see how we want to make the units the same, because now that's going to be the same as that. Okay, well, that, when you put that into your calculator, is this. Kilometers per 1 minute. There's that unit rate again. Okay, how about the sprint, the 500-meter dash? Okay, well, the 500-meter dash, I need to turn that 500 meters into kilometers. Well, 500 meters is 0.5 of a kilometer in 2.5 minutes. So when I divide, I get 0.2 kilometers per 1 minute. Okay, well, surprisingly here then, well, not surprisingly, which one are you faster in? Well, you're going faster here at 0.2 kilometers per minute. So you were faster when you were in the dash, right? Which makes sense. You're still going pretty darn fast in the 10K race, in my humble opinion, but I'm a pretty slow runner, so what do I know? Okay, last one. We're going to be asked to interpret some graphs in this unit, and we're going to want to be able to figure out, okay, again, a lot of times you're starting to see how I'm going faster, which one's going quicker. Okay, well, what we want to remember is if I want to figure out how fast I'm going, what I'm going to do is I'm going to use slope. Now, slope, we do have a formula for it, friends. It's change in rise over change in run, if you want to use that. But friends, here's the quicker way. All I'm going to do is this. I'm just going to draw a triangle. I'm going to say for runner one here, I'm going to say how far up did they go? What was their distance? Well, I can see from 30 to 10, they went up 20. But what I really just did in my head was this. But you can probably tell me that's 20 just by reading it off the chart. Okay, how long did it take them? Well, they're running at this consistent rate. So how far over? Well, 3 minus 1 is 2. So this person's speed is 10 meters per second. Okay, what about runner 2? Well, runner 2, again, I'm going to just think of my triangle here, just like that. And I say, how far up did they go? Well, they ended at 8, they started at 4. So if you wanted to use the formula, you would write it like that, or you could just say it's just 4. How far over did they go? Well, they ended at 3.2 and they started at 1.6. So they went up 1 point, or went over 1.6. Okay, divide those two things, 2.5 meters per second. Okay, so clearly I could tell in the first place that runner 1 was going faster, but now I can justify it using some mathematics. So if you want to remember your slope formula, there it is. But again, all you're doing is how far up did I go? How far over did I go? Okay, friends, so there is rate, ratio, and unit rate.